everyone. In this video, let's learn how we can add two 8-bit numbers using full adders in Simulink. In previous videos, we showed that the internal circuit of a full adder is shown as follows. It takes 3 inputs and it will output sum and carry out. So this will add 2 bits, AI and BI. If we want to add 8-bit numbers, we need to cascade 8 full adders together. So let's start. Let's start designing one full adder, and then we can make another 7 and cascade them together. So first we need an XOR gate. We can search in library, but I prefer to search in Simulink, typing XOR. And then we need 3 inputs, so we can double click and type 3. And then we need 3 AND gates. So we can double click, type and we can copy it 3 times. We need 1 OR gate for the C out that takes 3 inputs. Now let's connect them. We need 3 inputs, AI, BI, and CI. So let me have some input ports, second, third. So this is AI. Second one we're gonna call BI. Third one is the carry in. And on the output we have the sum. So let's have some output ports. This is the sum, and we can make copy. And this is the carry out. C out. Now let's connect them. So for the XOR gates, it takes all 3 inputs, AI, BI, and CI. Let's arrange them. For this AND gate, we need AI, BI first. That's AI, we can branch it from here. BI, we can branch it from here. And then for the second AND gate, we need BI plus CI. So that's BI. And that's CI. The third AND gate, we need AI, CI. So this is AI. We can branch it from here. And this is CI. And now these go in the OR gate. And that's our first full adder. So let's make it subsystem. We can select everything, go to Modeling tab, and create subsystem. So now I don't need this anymore. We're going to delete it. Let's make it a little bit bigger and arrange it. So now let's rotate it. Let's rotate it 90 degrees. So we can right click, format, rotate clockwise. And let's arrange also the input ports. So let me switch these two because we're gonna have the carry out is gonna be a carry in for the other full adder. So let's just double click and just renumber them. So this will be number 2 and this will be number 1. So that's sum to the right and then C out to the left. So that's our first full adder. So let's create, because we're gonna add 8 bits, so we need 8 of this. So let's make copies. This is the second copy. Let's make 2 more. That's 4 full adders, and let's make 4 more. So that's 8 full adders. We can now add 8 bits. Let's just rearrange them, make it clear. So the carry out from the first full adder will become the carry in for the second full adder. The carry out from the second full adder will become the carry in for the third, and so forth. So let's do that. So we can branch this, delete this, and feed it directly in the second full adder. We don't need this anymore. So let's do the same for all the rest. So let's feed it. Carry out to the carry in, carry out to the carry in, carry out to the carry in, carry out to the carry in. So that's it. This is basically our 8-bit adder that add 2 8-bit numbers. So it'll take A and B numbers, which are 8 bits, and then it'll output 8 or 9 bits. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So now let's test our model. So to make sure it's working as expected. So let's start with, if we do 1, 1, 1, 1, 1, 1, 1, 1. Let's say this is our A number and this is our B number. Let's have all ones as well. So the carry in here is 0, is always 0. So the first full adder will add these 3 bits. So 0 plus 1 is 0 with carry 1. The second full adder will add these 3 bits. So 1 plus 1 plus 1 is 1 with carry 1. Same thing here, 1 with carry 1, 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 and here 1, and we will have carry out 1 that will come down here. So if we add these two numbers, so we should have 1, 1, 1, 1, 1, 1, 1, 1, 0, which is 9 bits. So let's test our design. Let's go back to Simulink and test our design, make sure it's working as expected. So let's have some input constants, and let's delete all of these because we're going to use the constant to test our model. So for the AI here, we used once in this example. So that's 8 bits. And for B, we also used once. One thing we have to do to test our model properly is inside each one, if we execute this model and then we show the data type, so these are booleans. But at the end, we want to see like, 9 bits. So we're going to use concatenate vector, but to do this, we need to do some conversion. So let's do data type conversion and convert each one to unsigned integer 8 is fine. Each one of the outputs. So we're going to do the same for the other full adders. Make sure it's connected. And the last one. Now this will be our output, so 9 bits. 1, 2, and then the carry out is the last one. So let's output it. Let's see this, what will be. So let's have it display, but before that we need to concatenate all of these numbers. So let's have vector concatenate, and then since it's 9 bits, we need 9 inputs for this vector concatenate. And since we're gonna go left to right, so this will be the carry out is the most left bit. So drag it here, and then we have the sum here from this full adder, sum 5 from the 5th full adder, 4th, and so on. And let's try to run our model. Let's expand it. And here the carry in was 0, so we rerun. There you go. The answer is as expected. 1, 1, 1, 1, 1, 1, 1, 1, and 0 at the end. So why did we convert to unsigned integer? Let's see if we don't convert. So let's delete this block and keep it Boolean data type and try to rerun our model. This will create an error because of the mismatch of input port. So here it's Boolean, but this is expecting a unsigned integer data type. So that's why we converted to unsigned integer. So if we go back, we have this data conversion block. This will resolve our issue. There you go. So let's test another two sets. Let's see if A is 0, 0, 0, 0, 0, 0, 1, 1, and B is, I'm just making it randomly, 0, 0, 0, 0, 1, 0, 0, 1, let's say. So let's add them, see what we get. So this is what we're supposed to get. 4 zeros, 1, 1, 0, 0. So let's see. Let's first start with A is 6 zeros from the left, 1, 1. So let's go back to our Simulink model. And this is A. So we said 6 0, 0, 0, 0, 4th, 5th, 6, and the last two are ones. And what B was 4 zeros, 1, 0, 0, 1. So 0, 0, 0, 0, 1, 0, 0, and the last one is 1. So let's run our model. So we got, this is the output, 0, 0, 0, 0, 0, 1, 1, 0, 0. Let's verify. There you go. That's correct. Zeros, 1, 1, 0, 0. Let's do one last set. Let's see if A is 0, 1. This is what we're supposed to get. So let's see, A is 7 zeros, 1. 4 fifths. That's 0, and the last one is 1. And B is 1, 6 zeros, 1. So that's 1, 0, 0, 0, 0, 0, 0, and 1. Run. So that's correct. We get 0, 1, and then 1, and then zeros to the left. So 0, 1, 1, 2, 3, 4, 5 zeros. So let's see. 0, 1, 1, 2, 3, 4, 5 zeros, 1. And 0 to the left doesn't matter. So there you go. This is how we design 8-bit that add two 8-bit numbers using Simulink. I hope this was helpful. In the next video, we can cover how we can subtract two numbers using 8-bit full adders in Simulink. Thanks for watching.